For this problem, the denominators are the same, so you're pretty much just going to ignore them. You're just looking at the numerators. So you have 4x minus 5 minus 3x plus 2. So you're just going to combine like terms here. So 4x minus 3x is going to give you just x. And then you have negative 5 minus 2, which gives you negative 7. And then you keep your denominator. It's over 3x, so it would be option 2. That's really all there is to it. In case you need to see it again, it was just the 4x went with the 3x. So 4x minus 3x gave us this x. And we had negative 5 minus a positive 2. So negative 5 minus 2 gave us the negative 7. The 3x was the same for each on the denominator, so we just kept 3x for the denominator. This one's very similar. The only difference here is now instead of having just a monomial for the denominator, you have a binomial. So 4x plus 7 is a common denominator already. It just so happens now it's a binomial. It doesn't change any of the math. You still have x minus x, and then you have 2 minus negative 5. So x minus x is just 0, so those cancel. So pretty much those are going to cancel each other out. And then you have 2 minus a negative 5, the same as 2 plus 5, so it's just going to be 7 on top. And then your denominator stays the same, so it's 4x plus 7. All right, so let's go ahead and get rid of those, and we'll look at it again. We have x minus x, which cancels each other out. That's why you don't have any over here. There's no x's. And then you have 2 minus negative 5, which is the same as saying 2 plus 5 gives us a 7. The denominator stays 4x plus 7. So your answer here would have been the third option of 7 over 4x plus 7. For this problem, we have denominators that are similar, but on this side, you have a positive 6 versus a negative 6 over here, and then you have a negative x versus a positive x over there. We want them to be exactly the same, and we want to do it without doing a whole lot of math. It's not very hard to do. Let me just write this out here. Okay, so to achieve what I need, which is this denominator to match that denominator, I need to do something that's going to make this 6 negative to match that negative 6, and then make this x positive to match that positive x. So it's real simple. All I have to do is multiply the top and bottom on the right one by negative 1. If I multiply them both by negative 1, so the top and bottoms both get multiplied by the same thing, I'm not changing the values. It's the same as multiplying the whole thing by 1. So it's just going to give me a different way of writing this. So I'm going to bring down my 5x minus or over x minus 6, and then I'm going to distribute my negative 1 into the 3x and then negative 1 into the 6 minus x. So I have plus negative 1 times 3x is negative 3x, and then on the bottom I'll have negative 1 times 6 is negative 6, and then negative 1 times the negative x is positive x. So if I want to rewrite this to where it looks like that, then all I got to do is rearrange them. So I'm going to bring down my 5x over x minus 6 plus my negative 3x over, this is where I'm going to rearrange, instead of negative 6 plus x, I'm going to have x minus 6. Now my denominators match. So 5x minus 3x is 2x, and my final answer is 2x over x minus 6, which is option 2. Alright, so if you had a little bit of tough time following it, all I did, this part I rewrote the original, and then as long as I multiply the top and bottom by the same value, then the value of this rational expression is not changing. I'm just rewriting it a different way. So negative 1 times 3x gave me negative 3x. The whole reason I multiplied by negative 1 is to change this 6 minus x to where it looks like x minus 6. So I changed the sign for the 6 to make it match over here the negative. And then I changed the negative x to a positive x to match over there, all by multiplying by negative 1. So that's basically it. All right, so real quick on this one, I'm not sure why option 2 didn't show up for me, but that's okay. We don't really need it. I can show you the math regardless. But if you look, you have denominators that are different than one another. If you remember in class, the only thing we had to do is then I had to take my x plus 5 and multiply it by 3 and then the x minus 1. So top and bottom both got multiplied by x plus 5. And then on the right side, I had the x minus 1 on the bottom coming over here and multiplying to the top and bottom on this side. That way my denominators match. As you can see, all of my options I do have showing have x plus 5 times x minus 1 for denominator. So all I have to do really is just multiply and see what we got. Okay, so I went ahead and set this up. As you can see, my 3 over x minus 1, which I have right here, is getting multiplied by the denominator that is on the other side, the one that was different. So x plus 5 divided by x plus 5 is the same as multiplying 1. So I'm not changing the value, but it's going to allow me to make the denominators common. So all I have to do is distribute the 3 into the x plus 5, just multiply all this together. And then the same thing on the other side. I have the denominator from this side now multiplying with my numerator on the other side. So I have x minus 1 times, or divided by x minus 1, same as being multiplied by 1, so I'm not changing the value here. But it's going to make the denominator the same. You can see the denominator here is going to be x plus 5 times x minus 1, and then over here is going to be also x plus 5 times x minus 1. So I can just go ahead and distribute. So now I'm going to combine the 3 into the 3x plus 5. So I have 3, and I could even write it as 3 and then parentheses x plus 5. But if I did that, it's not going to match my options that I have for my answers. So I have 3 times x is 3x, 3 times 5 is 15. All right. And then, so I got 3x plus 15. I'm going to bring down my x plus 5 times x minus 1. And then I have minus 2 times x minus 1 is going to be 2x minus 2 over. And then I'm going to bring down my x plus 5 times x minus 1. All right, so what happened here? This 3x plus 15 is a result from 3 times x plus 5, and then 2x minus 2 is a result from the 2 times the x minus 1, and then the denominators just combine to make them one common denominator of x plus 5 times x minus 1. You have that on both sides now. So now all I got to do is combine like terms. 3x minus 2x is x. 15 minus a negative 2 is positive 17. Okay, and then I'm going to bring my common denominator down of x plus 5 times x minus 1. Looks like the answer is the first option. So it's a good thing I didn't have that one missing. I couldn't even have circled it for you. But if we look at it, again, this x plus 17 came from 3x minus 2x, which was just positive x, and then 15 minus a negative 2, which was positive 17. Then I brought my denominators down. Once the denominators are common, I don't have to worry about them anymore. They just carry on through. I just got to worry about combining the numerators. Thank you. All right, this is the problem that I expected a lot of you might have trouble with. And that is because this x squared minus 16. Now, we've talked about those before, but I doubt you remember. It's just the difference of squares. This probably gave you a little bit of a hint that all your denominators were x plus 4 times x minus 4, which if you were to multiply those binomials together, you will get x squared minus 16. But when we have a difference of squares, which is to say that we have an x squared minus a perfect square, in this case 16, then we can pretty much factor it out into two binomials, and in this case it'd be x plus 4 times x minus 4, which we have here. That's because the square root of 16 is 4. So since the square root of 16 is 4, if I have x plus 4 times x minus 4, what happens is I end up with x times x, which is x squared, which we have. Then we end up with a negative 4x and a positive 4x, which cancel each other out. That's why you don't have a b value. Then we have 4 times negative 4 gives us the negative 16. All right, so all of this common denominator we have, is the factored form of x squared minus 16. Technically, all of these, you could have just left it as x squared minus 16. But we like to show in factored form, that way we can see where that, is coming from, where all the math's going. So let me show you how you would do this exactly. Okay, so I rewrote this so we can work on it a little bit. First thing we got to work on is this denominator, putting it in factored form. Again, since it's the difference of squares, all I have to do is take the square root of 16, which is 4, and now I'll rewrite it as x plus 4 times x minus 4. It's going to be like that every time you have a difference of squares. If it's an x squared minus some sort of perfect square, so whether it be 16, 25, 36, whatever you have, then you're just going to take the square root of our constant and put them into a form where it says x plus that value and then x minus that value. So x plus 4 times x minus 4, and that gives us the x squared minus 16. All right, and so you need to make sure you pay attention to this, because you will have one on your quiz that we're going to take that's exactly the same. All right, so on the right, all we have is the x plus 4 on the bottom. So since we only have the x plus 4 on the bottom, we need to basically multiply the top and bottom by x minus 4, because we've got part of it. We've got the x plus 4 that matches, but we also need the x minus 4. So we need to multiply by the x minus 4 on the bottom as well. So that means the top and bottom gets multiplied by x minus 4. Just like every other time, it's the same as multiplying by 1. All right, so what we have to do now is we'll distribute the 5x. So I can bring down everything that we have on the left side. So we have 3 over x plus 4 times x minus 4. And then we're going to say plus 5x times x is 5x squared. 5x times negative 4 is negative 20x. And then I'm going to bring down my denominator of x plus 4 times x minus 4. All right, so to get this value, 5x times x gave me the 5x squared. 5x times negative 4 gave me the negative 20x. All right, and then I just had x plus 4 times x minus 4 that came down from my denominator. So now all I got to do is put everything together. And putting everything together gives me 5x squared minus 20x plus 3. And that's all over x plus 4 times x minus 4. So let's see which option that is. Looks like it's the last one. It's option 4 is the answer.